Welcome to the MathCat channel, where our math lessons are innovative, creative, and short. As a math teacher, I try to teach one concept in each video, and then link a lot of videos together. If you haven't already, please take a second right now and subscribe to the MathCat channel, so you'll know when new videos come out. You can do that by clicking on the icon in the corner of the screen. Today's lesson is on permutations with duplicate objects, and I'll be back at the end to show you the links to other videos. As an example of what I mean by duplicate objects, we'll take a word with duplicate letters in it, like the word I. Notice I've colored the E's differently so that we can tell them apart. How many ways can we reorganize the letters in the word I to make new words? Well, we'll start with the red E, and then we'll make combinations with the Y, and then we will start with the blue E. And if we look at the results, we notice some of them are the same except for the color of the letter E. For example, EYE is twice. So we only need one of those if we're just counting letter reorganizations. And YEE is the same, twice, so we can eliminate one of those. And EEY is found twice, so we can eliminate one of those. What we're left with is three ways to reorganize the letters. So for a formula, let's say that we had n objects, and then we count up how many of each type of object within that total. We call those n sub 1 and n sub 2 all the way up to n sub k. In the word I, for example, we have three objects. We have E, a Y, and another E. But if we look at types, we only have two types. We have E's and we have Y's. And we can count up each one. We have two E's and we have one Y. Now if we add these two numbers together, we should come up with the total number of objects again. It's kind of a way of double checking your work. So our formula then would be the total number of objects, n factorial, divided by each type factorial. And if we put numbers in, number of objects we have are 3 factorial, and we divide by E, which is 2 factorial, and Y, which is 1 factorial. We can expand that. 3 factorial can be written out 3 times 2 times 1, and 2 factorial is 2 times 1, and 1 factorial is simply 1. Now we can simplify this fraction, and we end up with 3, which is the number of ways we found in our example we could rearrange the letters. Let's take another example. How about the word pineapple? How many ways can we rearrange the letters in the word pineapple and make new words? Well, n in pineapple, the number of objects or the number of letters is 9. And then if we list each type of letter, we have a P, an I, we have an N, an E, we have an A, and an L. How many of each type now? Well, this would be our N1 through N sub 6 in our formula. So we count up the number of each type of letter. We have 3 P's, for example. And we have 1 I, we have 1 N, we have 2 E's, we have 1 A, and 1 L. And if we add up all of those types, this is a way to double check that we haven't missed any. We have 9, and that's the same as the number of letters in our total word, so we haven't missed any. So you always want to double check your work. Let's use our formula now, which says we take the number of letters, n factorial, and divide it by each type factorial, n1 through n6 factorial in this case. So if we plug in our numbers, we have a total of 9 letters factorial, divided by 3 factorial for P, 1 factorial, 1 factorial, 2 E's is 2 factorial, and 2 more 1's. So we write that out longhand. We'll expand to 3 factorial and we'll expand to 2 factorial because 1 factorial is simply 1. And we'll simplify the fraction. And if we multiply all that out, we come up with 30,240 ways to rearrange the letters in the word pineapple. That's the formula for permutations with duplicate objects. I'm going to put up a link right now for a video for permutations without duplicates and where there's no repeating letters in the words that are formed. And then I have one more video, I'll put up the link right now, that shows you the formula when you can repeat letters in the words that are formed. If you haven't already, please take a second right now and subscribe to the MathCat channel. You can do that by clicking on the icon in the corner of the screen. And if you have any questions or comments on this video or other videos you'd like to see made, please write them in the comment section below. And thanks for watching.